Hey guys, this is Mrs. Cook. Here are the objectives that we're going to cover in this lecture. You're going to be able to identify the following on the periodic table. We're going to talk about groups, families, periods, representative elements, transition metals. We're going to talk about characteristics of metals and nonmetals and metalloids, as well as alkaline earth metals, alkali metals, halogens, and noble gases. We're also going to describe the organization of the modern periodic table and why it's laid out the way it is. And we're going to classify elements as metals, nonmetals, and metalloids. And then finally, we're going to describe common properties for groups of elements on the periodic table. You guys already printed a periodic table, and we started to use it last unit when we were looking at the subatomic particles of protons, electrons, and neutrons, and we talked about atomic mass. But why, other than that, is the periodic table important to us in chemistry? The periodic table is the most useful tool that we'll use in this class. You get to use it on every single test, and it organizes a lot of information about the known elements. Prior to the periodic table, the organization of the elements was a mess. There was no organization whatsoever. So we knew certain characteristics about elements, but there was no categorizing of the elements or looking at similarities between elements. So imagine going into a grocery store that had no organization. So let's say you were looking for a certain type of bread that you wanted to get, but there was no bread aisle. It was just, hey, walk through the aisles and try to find this type of bread that you want. It's kind of how the elements were. So it was really difficult to find information. You guys might be able to relate to a messy bedroom. So same kind of thing, you're looking for maybe your practice gear for basketball practice and you can't find your shoes because your room's not organized. So there was a real need to organize the elements by properties. Which brings me to this side. So how did the chemists begin to organize the known elements? Early chemists used the properties of elements to sort them into groups. So they started looking at similarities based on properties of elements. And we haven't talked about properties at all yet in this class, so I just wanted to highlight definitions as well as a few examples of both physical and chemical properties. Because chemists use physical and chemical properties to categorize the different elements, or look at how, the similarities of them, we really need to know what a physical and chemical property is. So a physical property is a quality or a condition of a substance that can be observed or measured without changing the composition. So for example, H2O. We're all familiar with water, and we know that the chemical formula of water is H2O. So we can look at the physical properties of water that do not change. So the density of water, for example, it doesn't matter if we have 50 milliliters of water or 1 milliliter of water. The density of water is always 1 gram per milliliter. So that would be an example of a physical property. The color, the luster, so that's like the shine. The state of matter that it's in at room temperature. So is it a solid, liquid, or gas at room temperature? Water, we know, at room temperature is always in a liquid state. So that would be a physical property. Other things like, does it conduct electricity? Or is it malleable, meaning able to be hammered or pressed permanently out of shape without breaking or cracking it? So those would all be some examples of physical properties of elements. We could also examine chemical properties of elements. A chemical property is the ability of a substance to undergo a specific chemical change. And so some examples of chemical properties would be, is the element able to react with an acid? Or can it react with a certain compound, for example, copper 2 chloride? So if it is able to react with those particular substances, we would call that a chemical property of that substance. It's able to undergo a change when it reacts with them. Other chemical properties that you will be familiar with are flammability, so is it able to catch fire, or corrosion, like rust. So as I was saying before, originally the elements were being discovered, and chemists were looking at different physical and chemical properties of these elements. And then what they started to do is they started to take those physical and chemical properties and they started to organize the elements in rows by increasing atomic weight, because we knew atomic weights of elements, and they also started to put the elements in columns by the way that they reacted, or their chemical properties and physical properties. There were some problems with this initial organization of Mendeleev. So Mendeleev was the first one to really give some sort of organization to the periodic table. The problems were he left some spaces for what he said were going to be undiscovered elements, and it turned out he was right. Those spaces were eventually filled. He also broke the pattern of increasing atomic weight to keep similar reacting elements together. Okay, so this one right here then led to our more modern periodic table. So Henry Moseley refined Mendeleev's periodic table. He made a few improvements, and now the elements are put in rows by increasing atomic number. So this is how it's currently organized. So if you look at our current periodic table and you start here at hydrogen and you move across a row, and then you move down to the second row and you move across, you'll notice that the entire periodic table reads like a textbook, and so the atomic number is increasing all the way down the periodic table. The horizontal rows, so that's this part here, we call these periods, and they're labeled from 1 to 7. So we can see by my numbering that there are 7 periods on the periodic table. So this first one here would be the first period, this is the second period, third period, fourth period, fifth period, sixth period, and seventh period. The elements are also organized into vertical columns called groups. So these would be our vertical columns going down this way here. And you can take a look at your periodic table, and they're labeled through 18. So all of these, I'm not going to write the numbers in, but they're labeled from 1 to 18, the vertical column. Groups are also referred to as families. And so each family has its own characteristic chemical properties and physical properties, which we'll talk about. Elements can also be further classified into representative elements and transition elements. So the representative elements have a little bit more regularity to how they react with things. So our representative elements are the first 2 columns on the periodic table, so the alkaline earth and the alkali metals, and then the last 1, 2, 3, 4, 5 columns on the periodic table. So we call those the representative elements, and those are going to be important to note as we go throughout this unit and we start to talk about valence electrons. The other classification is the transition elements, or the transition metals. And so the transition metals are found in this area here on the periodic table, along with the 2 rows that are at the bottom too, that are not on this particular picture. Because of how the periodic table is laid out, it's also organized by metals, nonmetals, and metalloids. And so these are the 3 classes of elements on the periodic table. And there's an overall metallic trend. And so the overall metallic trend is that the elements become less metallic and more non-metallic across the periodic table. So what that means is as we move across a row on the periodic table, elements generally become less metallic. You might be wondering, well, what does less metallic mean? Metals have their own unique physical and chemical properties, and so do nonmetals. And so when we say something is less metallic, it's becoming not as good of a conductor. So metals are going to be good conductors. They have high luster or sheen, generally. They're generally solid at room temperature, and the exception to that is mercury. So all of the rest of our metals are going to be solid at room temperature. They're ductile as well as malleable. Properties of nonmetals are generally poor conductors, and the solid nonmetals are very brittle. And a lot of our nonmetals also will be gases at room temperature. Metalloids are the new one probably that you're like, oh, I've never heard of that, or maybe you have. The metalloids have properties of both metals and nonmetals, and they border the staircase. So on the periodic table, you guys will all see this bold line, which is the staircase. Any element that is touching that particular staircase is classified as a metalloid. And so what you'll see is if you test the physical and chemical properties of the metalloids, they'll basically show properties of both metals and nonmetals. So just by simply looking at the periodic table, we can know whether an element is a metal, nonmetal, or metalloid. That staircase is the key to it. The staircase separates the metals from the nonmetals. So anything to the left of that staircase is classified as a metal. And then we have anything to the right of the staircase being classified as a nonmetal. And then the last part, those elements that are bordering the staircase, are classified as your metalloids. There are so many things that we can infer about elements on the periodic table just by looking at their position on the periodic table. Which row are they in, or which period are they in? Which group are they in, or which family do they belong to? We can also know things about their metallic or non-metallic properties. So over the next couple of days, we're going to just investigate this and learn a little bit more about these elements and the chemical and physical properties that they exhibit.